The bypass that could change the world. The world is only a few miles away from panic. A single narrow strip of water holds together the engines of modern civilization. Oil, gas, plastics, fertilizer, pharmaceuticals, the invisible foundation of daily life, all of it depends on one fragile passage. This is the Strait of Hormuz, a bottleneck so small and so important that if it stops, the shock is felt across the entire planet. Nearly 20 million barrels of oil pass through these waters every single day. Tankers from Saudi Arabia, the UAE, Iraq, Kuwait, and Qatar all converge here, forced through one narrow opening before they can reach the open ocean. And that is the problem. Because when the world builds its future on one corridor, that corridor becomes a weapon. On one side, Iran. On the other, Oman and the UAE. A corridor of energy, money, and power, but also fear. Military escorts are routine here. Naval patrols are constant. The tension never leaves. Every captain navigating these waters knows the truth. If this strait closes, the world does not just lose oil. It loses certainty. Prices surge. Supply chains crack. Markets panic. Entire industries begin to choke. Factories slow down. Shipping freezes. Economies stumble. The whole machine starts trembling because one geographic choke point has been severed. And for decades, the world has known this vulnerability. Threats of blockades, seized vessels, naval minefields, war games, insurance shocks, diplomatic standoffs. The Strait of Hormuz has always carried more than energy. It carries risk. So the question was inevitable. What if the world could bypass it entirely? What if the most dangerous choke point in global trade could simply be removed? Not with diplomacy, not with warships, but with engineering, a man-made passage, a new route from the Persian Gulf to the Arabian Sea, a bypass through the mountains, a canal where no canal should ever exist. On paper, it looked impossible. In reality, it looked worse. Because between the Gulf and the open ocean stands the Musandam Peninsula, a wall of savage terrain and broken rock. The Hajar Mountains rise out of the earth like a fortress. Limestone ridges, fractured cliffs, hollow caverns, brutal gradients, no roads, no infrastructure, no easy access. One of the most hostile landscapes in the region. And yet this was the only path. Not across flat jungle like Panama, not through open desert, but through vertical mountain. A route barely 32 kilometers long, shorter than Panama, yes, but unimaginably harder. Peak elevations rising hundreds of meters above sea level. Slopes so steep, a single mistake would send machines into the sea. Cavities hidden inside the rock. Fresh water trapped inside the mountain. Unstable slopes hanging directly above the proposed route. This was not just excavation. This was battle. Before a single blast could be triggered, the mountain had to be understood. Survey teams were sent into terrain with no roads and no infrastructure. Equipment had to be flown in by helicopter. Sensors were planted across the rock face. Seismic instruments mapped the hidden cavities beneath the mountain. Underground voids were discovered, some vast enough to swallow entire structures. Cathedral-sized cave systems hiding inside what looked like solid rock. The mountain was not solid. It was fractured, hollow, alive with risk. A freshwater lens hidden within the mountain created another nightmare. Breach it during construction, and the entire excavation could flood before the canal was even finished. So the engineering plan had to change. Every route, every blast sequence, every cut had to be redesigned around geology that seemed determined to resist human ambition. 3 routes were studied. A northern route, shorter but passing through even more brutal peaks. A southern route, longer but less direct, and the central route, 32 kilometers through the heart of the problem. The central route was chosen, not because it was easy, because it was the least impossible. And even that route demanded a scale so absurd it barely sounds real. 3 lock systems, a channel 300 meters wide, 25 meters deep, hundreds of millions of cubic meters of rock to remove. A project so large it would require moving more earth than some of history's greatest canals combined. But first, the mountain had to be opened. Before canal excavation could even begin, access had to be created. There were no roads, so roads were blasted directly out of the cliff face. Workers drilled into vertical rock walls above the sea. Explosives were set. Sections of cliff collapsed away, and after each blast, crews moved in by hand, clearing ledges wide enough for trucks to pass. This is how roads began in the mountains. Not built from above, carved from the side of the world. Equipment arrived by sea because there was no other way. Machines were lifted ashore by crane onto temporary jetties. Then they were forced up gradients, so steep that one wrong move meant total scoot. Machine, operator, everything over the edge. For months, all they did was build the ability to build. Roads, camps, water, power, medical support, shelter. Tens of thousands of workers could not survive here without an entire artificial ecosystem built first. Fresh water had to be created through desalination because the nearest reliable supply was too far away. Power stations had to be built because no grid connection existed. Before the canal could begin, a city of infrastructure had to appear in the middle of hostile rock. Only then could the real work start. The blast plan alone stretched for thousands of pages. Every cubic meter of mountain assigned a blast number, a charge size, a sequence. Tens of thousands of detonations planned before the first major explosion ever touched the rock. Every cavity underground had to be stabilized. Every vibration had to be monitored. Every collapse had to be controlled. The first blasts were small, carefully observed, recorded in extreme detail, used to calibrate how this mountain would break. Cameras captured the fractures. Sensors tracked the ground movement. Engineers adjusted the model. Then the production blasting began. And in seconds, mountains started disappearing. Tens of thousands of tons of rock torn apart in a single blast. Excavators flooding into the cuts. 100-ton dump trucks rolling non-stop, carrying the mountain away day and night. One truck after another. Then another. Then another. A constant industrial heartbeat. The mountain was leaving on wheels. Drill holes were punched into every blast face. Explosives loaded with millisecond precision. Too much fragmentation, and the site vanished in dust. Too little and the rock became too massive to move. Everything had to be exact. Water cannons suppressed choking clouds. Night shifts followed day shifts. The blasting stopped. The excavation never did. Then new dangers appeared. Groundwater began seeping through fractured limestone. Pump systems had to be deployed immediately. Permanent dewatering networks were installed to keep the cut dry. Elsewhere, unstable slopes threatened to bury crews beneath hundreds of thousands of tons of fractured rock. Routes were shifted, surveys repeated, blast patterns redesigned. Time was lost. But the mountain gave no discounts. At one section, the open cut was not enough. The highest peak along the route could not be removed from above. It was too tall, too brutal, too dangerous. So the solution changed again. A tunnel boring machine would drive through its base. While the open excavation ripped through the landscape from above, the TBM attacked from within, grinding through the hardest limestone, meter by meter, hauling spoil out behind it. Underground and open-air construction advanced toward each other until, finally, the route connected. Sea to mountain, mountain to tunnel, tunnel to cut. For the first time, the full canal line existed, and even before it was finished, the world reacted. Because this was never just a civil engineering project, it was a geopolitical earthquake. The moment a real bypass seemed possible, the meaning of the old strait began to change. Risk premiums shifted, markets adjusted, shipping commitments moved. Money started flowing toward a future where Hormuz was no longer the only gate. And that terrified everyone whose power depended on that gate remaining irreplaceable. Because a bypass like this does not just move ships, it moves leverage. For decades, strategic power in the region was tied to one truth: the strait could be threatened. That threat shaped diplomacy, military strategy, insurance costs, naval deployments, and global energy anxiety. But if the oil could escape another way, then geography itself had been overthrown. That made the bypass one of the most valuable assets on Earth, and one of the most vulnerable. Security had to be built into everything: airspace restrictions, monitoring systems, surveillance infrastructure, defensive planning. Even the digital systems controlling the canal had to be protected, because sabotage would not only come from land or sea, it could come through code. The bypass had to survive everything: heat, dust, geology, water pressure, human error, political hostility, and the possibility that the moment it opened, it would become a target. But construction kept moving. Once the main excavation was completed, the raw canyon had to be transformed into a waterway. Concrete walls replaced exposed instability. Waterproof membranes were installed. Rock faces were converted into engineered surfaces. The floor was lined smooth enough for supertankers. Raw mountain became controlled geometry. Kilometer by kilometer, the canal stopped looking like a construction site and started looking like a shipping corridor. Then came the locks. Because this route could not simply be cut open to the sea, the elevation changes demanded a system powerful enough to lift and lower some of the largest ships on Earth. Massive lock basins were carved into the rock. Reinforced concrete walls rose to contain unimaginable water pressure. Steel gates, enormous beyond normal comprehension, were fabricated, shipped in sections, floated into position, and moved into place with terrifying precision. Each one had to work perfectly, because when a chamber fills with millions of tons of water, there is no room for error. The locks became the beating heart of the project. Water rising, water falling, ships ascending through the mountain, then descending toward the Arabian Sea, a mechanical conquest of elevation itself. At the same time, the approaches had to be built, seabeds dredged, breakwaters constructed, port facilities installed, radar coverage extended, camera networks stretched across the canal, tug berths, fuel points, control systems, emergency response infrastructure, all of it necessary to transform raw engineering into an operational artery of global trade. This was no longer a trench in the mountains. It was becoming a world system. And finally, after years of blasting, drilling, pouring, hauling, stabilizing, redesigning, pumping, lining, securing, and assembling, the project faced its ultimate test. Opening day, the first vessel enters the channel, not through a natural strait shaped by geology, but through a passage forced into existence by human will. A ship moves into the lock chamber. Water rises. Steel holds. Systems respond exactly as designed. The vessel advances deeper into the cut. through concrete walls that were once solid mountain, through a route that did not exist until men and machines carved it out of one of the most hostile terrains on Earth. At the same moment, the larger meaning becomes impossible to ignore. The old bottleneck is no longer absolute. The old fear is no longer total. The old map no longer controls the future the way it once did. The bypass does more than save time. It changes calculations. It changes markets, the way it once did. The bypass does more than save time. It changes calculations. It changes markets. It changes military strategy. It changes who holds pressure and who escapes it. A new superhighway for global energy emerges, and around it, new ports, new terminals, new infrastructure, new economic zones begin to grow. What started as a solution to a choke point becomes something larger. A logistics empire, an energy corridor, a strategic reordering of the region. For the mariners who once had no choice but to pass through the most dangerous bottleneck on Earth, the nightmare finally has an alternative. For the producers trapped inside the Gulf, wealth now has another exit. For the markets that lived in fear of one closure, one crisis, one escalation, one miscalculation, the world suddenly has breathing room. And that is why this project matters. Not because it is large, not because it is expensive, not because it is dramatic, but because it proves that sometimes the most powerful force in geopolitics is not an army, not a fleet, not a treaty. It is infrastructure. $100 billion answer to a centuries-old geographic trap. Millions of tons of earth moved. Thousands of workers pushed to their absolute limit. Mountains cut open. Seas connected. A new route forced into existence where nature never intended one. This is what mega engineering really is. Not just concrete and steel, not just tunnels and locks, but the moment human ambition looks at hostile geography and refuses to accept it. The Strait of Hormuz was once the bottleneck of the world. Then someone imagined a way around it. And once that idea became reality, it didn't just change the route. It changed the balance of power. It changed the economy. It changed the map. And it changed the world.